that doesn't want to be here, can I kindly ask you to please, if you want to go out, please leave. I have to talk through the lecture because we're recording it. Okay, so I'm going to continue. This is a review lecture of Computer Programming 143, and we are already now at lecture 25. So I'm not going to do the pointers lecture again, because we did that in the previous review. I just want to focus on this one lecture this week on the start of file processing. So can I sort of see a show of hands? Who of you guys are comfortable with file handling? Obviously only the first years. Or if the other years are also struggling with file handling, you're in the right venue. So, okay, so you guys, the first year computer programming students, how are you feeling with file handling? Good? Not good? Not good at all. Okay. It's good that you're here. This is a very important part of the practical for this week, the computer programming practical. You're going to read your data from files. So it's very important that you can handle ASCII files, at least. All right? So we're going to look at handling ASCII files now. And okay, so this lecture over here is, let me just full screen it. Okay. We are already at chapter 11. So all the content that I'm presenting here is covered in chapter 11. Essentially what we're going to look at today is what is files. Now, if you think back to the beginning of the computer programming lectures, you remember that we had different storage media. We had primary storage and we had secondary storage. So primary storage happens when your program starts, then your program is loaded into random access memory, RAM. That's a volatile memory of your computer, okay, and your program sits there. So that's the primary storage. The secondary storage is, and all arrays, sorry, just to get back to the previous point, all arrays and dynamically allocated memory and pointers and everything like that resides in this RAM, all right? Now we also showed you in the beginning, that there's a secondary storage type. And that secondary storage is the hard disk, okay, the hard drive. And that is where these files reside. So if you have a lot of information, and you want to store it somewhere, that you can keep it there, even though the program stops or the power is shut down or anything like that, then you would use files. Okay, so a file resides in the secondary storage on the computer's hard drive. Okay, so now that you guys, and they're very useful because they retain information. Obviously, the hard drive stores image files and Excel spreadsheet files, and as you guys will see in the practical, for example, usage files in a comma-separated format, things like that. So if you look at what type of files you get two types of files. Firstly, ASCII files, which is readable format. So it's like you can open it with a text editor and you can view the input. But then you also get binary files. And binary files is not the focus of this lecture. We're going to look at that next week, binary file access. Today we're only going to focus on ASCII, on text file processing. Okay, so all these files are what we call data files. So they can be created, updated, and also processed by C programs. So what we mean with processed is that we can read the file from the hard disk. So as I mentioned to you guys, they're used for permanent storage of large amounts of data. As the storage of data in variables and arrays is only temporary, because this information that sits in your program in form of variables and arrays and things like that, that is only in RAM, and that's volatile. So you use files when you want to transfer information into a permanent storage medium on your computer, which is the hard disk. So, as I said, there are two types. Binary files, where essentially we get unformatted data. We also refer to the raw bytes. And typically you cannot read this. So this is not readable by humans. It's readable by programs, obviously, because the bytes represent information. And these files, these binary files, can be written and read sequentially and randomly. So in our lecture today, just to get started on files, how it works, and where it sits on the computer, we're just going to look at sequential access of text files. Okay, so text files is the thing that we're focusing on. In this file, this type of file, data will be stored as characters. And a character in C is of type char. So these text files are usually written and read sequentially. So that's what we're going to do today. So one character after each other. That's what it means sequentially. Okay, so first thing, this file now sits somewhere on a hard drive in memory. You are going, before you can do anything with it inside your program, you will have to open it. And to open it, we use a routine called fopen. So usually all these file handling methods or functions starts with F. So fopen, you'll see later scanf, readf, fput, all sorts of stuff. But it usually starts with the F. But all of these functions are contained in the standard IO library that you guys include already now by default almost. Okay, so when we open a file, before we open it, we have to declare a pointer of type capital letters file. And this declaration resides in the file io.h, the standard io.h library. So the fopen, what this routine does, is it returns a pointer to this file object, so that my program can, when it refers to this pointer, it knows that it's talking to this file that resides in on the secondary storage. Okay. So in this example, this file takes firstly the file name, some file name.xyz, and then it also a second argument. This argument over here is an R, and this specifies that we want to open this file for reading from it. There's quite a number of specifiers over here. We're going to see a list of that in a table now. But this one specifically tells us that we want to open this file for reading from it. And it's a text file. Now, when you're finished with the file, it's very important to close it again. Because other things, other programs and other aspects might want to use that file again. And if the pointer to the file is already occupied by another program, then something else cannot access it and manipulate it. So it's very important that when you finish with the file, you call this routine fclose, and you give it the pointer that was assigned to you when you called the fopen routine. Okay. Now, as I said, for this second argument, this argument over here, where we used R, there's a number of these things. There's a number of these keywords that we can add. We can add an R, as I said. It opens a file for reading. We can also specify a W. Now, W means that you're going to create the file for writing. But then the question comes up, what happens if the file already exists? Well, in that case, the content of that file is going to be discarded. But if you don't want to discard the content, so if you don't want to wipe the content that's already in the file, you can also open the file with this specifier A. So what this specifier A will do is it will append. So any new content will be written at the end of the file. So R plus, that means open it for updating. And with updating, I mean reading and writing. W plus means create a file for update. If the file already exists, we discard the current content. And A plus means open the file for reading and writing, but the writing will be done at the end of the file. So we append it. Okay, so these are all these first routines over here. Those are all for manipulating text files. Second flavor is, as you can see, it's exactly the same as these, except now we get this little letter B at the end. And this means that we're going to open a file for reading in binary mode. Remember, if it's a binary file, and you open it, you won't be able to read. It's not human readable. It's also a more efficient way of storing information. But we're going to compare some files. We're going to compare text files to binary files next week in our review lecture then. This lecture is only going to be focused on text file writing and reading. Okay. So how does the C program now look at the file? So it views a file as a sequence of bytes. But obviously the program has to know when this information is going to stop. And for it to stop, we usually mark the file with an end of file marker. So it's a special character, you can see it as a special character that's written to the file that indicates the end of that file. And we have routines in C offered by the standard IO library that can check whether this character has been read. And then it knows that my program should stop reading information now because I've reached the end of my file. So we're going to see an example a bit later how that works. Okay, so what is a stream? A stream, remember your file sits there in the secondary storage in memory, and then we need to transfer information between that file that sits in memory and the program that resides in RAM. How does that work? And to do that, we use a stream. So a stream can be seen as a communication channel between the file and the program. So we're going to open when we open a file, it returns a pointer to what we call a file structure. And this contains information about how this flow of information can be handled. So when a program starts out, there's actually 3 streams that starts. It's the standard input, it's the keyboard stream. So it's anything that inputs information. There's the output, there's a standard output stream, which relays information to for example, your screen. And then there's also a standard error stream that also relays information to error. Don't worry too much about that at the moment. It's just some default behavior that's initiated when a program starts. Now, remember, we declared a file pointer, and this file pointer was of type file. Now, this file is actually a structure, a struct, and that's defined in standard IO.h. So, it's a file descriptor, and it's an index into an operating system array, the open file table. And this open file table essentially controls another thing called the file control block. And this file control block is used to control how the file works and when it access to the file, for example. Okay, so this is there is also a very nice diagram in the book. Let me just find where it is, and I can give you guys a reference. It's figure 11.4 in the textbook. So maybe if you want to make a note, go look at that. Have a look at that. It tells you that what happens when you open the file with a pointer. It returns a pointer to this file structure, and then this pointer essentially is an index in what we call an open file table, in a table. Okay, and this index in the table points to this index in the file structure points to an element of the open file table that contains this file control block. This file control block will manage the access that you have with regards to this file that resides on secondary storage. But a good overview is figure 11.4. Okay, so how are we going to interact with the file? What are we going to do? How are we going to get information from the file, and how are we going to write information to the file? So we do that with a couple of useful functions that's defined in the standard C library. And this is if, as I said, a lot of them starts with the if get C. So there's if get character, and we give it our pointer to the file. This reads a character from a file. It's essentially equivalent to get char, that you guys also have used, I think. Then there's also a way to get a line, a whole line from a file, and this would be the fgetS, which stands for string. So this is fgetC, the C stands for character, and this is file get string. So it returns, obviously it returns a character pointer, and it reads a line from a file. Then there's also other routines that's very similar to the scanf and printf routines that you guys have used a lot. There's fscanf, that also essentially reads a particular string from a file, and there's also fprintf that is similar to printf, just prints information to the file. The way in which these differ, there's a couple of subtle differences. For example, fgetS, this one, reads information until it gets a new line, while this fscanf reads information until it gets to a white space. Okay, so that's some subtle differences that you guys can test out and play around with. As I said, as was noted in a couple of slides back, we need to have some form of an indication when the file has ended. And to do that, we look for the end of file indicator. That tells us there's no more data to process. So there's a function called fEnd of file. So it looks, are we currently reading the end of file specifier in the file? If it is, then it returns true, otherwise it's false. So this just gives us true or false, are we at the end of the file or not? Now, for sequential accessing, remember every time you're in a file, you open the file, and you read, you call fgetC, you read a character. There's a pointer in that file that moves from one spot to the next spot. And it goes through all of those characters. If you get to a point and you realize, oh, I got to go back to the beginning, then you need to use a function called rewind that essentially resets the file position pointer to the beginning of that file. Okay, there's an example that was also listed here in the slides. But what I've done is I've essentially implemented these two functions in our Eclipse environment, and I would rather look at that now. Okay, so what we have over here is, let's look at it. Start from the top. I've got my standard io.h library over here. I've got my standard library, standard lib.h and standard io.h. And then I've declared two functions. I've declared a write content to file function and read content from file function. So the purpose of my write content to file is just going to take a file name and it's going to write arbitrary content into that file. And then read content from file again takes a file name, and then it just reads content from that file and displays it on the screen. Okay, so two functions that doesn't return anything, but that takes a file name, a character pointer as an input argument, and it accesses, it attempts to open that file and then do some things with it, like write content to it or read content from it. Okay, so if we look at, now I'm going to kick off with my main. My main over here, firstly I define a file name, so I just declared it as about 30 characters big, and I call it test.a. We can call it anything else. Let's call it computer programming 143 test.text. You know, the setbuff routine, that's just used to fix Eclipse. And what I then do is I call my write content to file, and I give it this file name over here. So before I read it, let's just first look at what I'm doing in this write content to file routine. So the write content to file takes a file name as an input argument, and then it starts doing things. Now let's look at what it's doing inside. Okay, so I'm going to work with a file. So I know that I have to declare a pointer to that file called f pointer, or whatever. You can call it anything, doesn't matter that, but it has to be of type file pointer. Otherwise, it's not going to work. Then I just want to declare over here, let's say, declare some dummy information to write to file. So I have a line of text that's 50 characters. I make provision for 50 characters, and I just say it's a single line of text. Then I also declare an integer, my int, and I initiate its value to 5, and also a float, initiate its values to 1.345. Now I just printf to screen something that says writing content to file. First thing I attempt to do is I attempt to open my file over here. So remember back is I call, and to do that I call the fopen routine. So fopen, I give it my file name, and I open it in write mode. There's no plus there. So what is going to happen if we okay, we're going to see now. We're going to create new files in each instance because there isn't a plus. So we're not going to append information. Okay, so this fopen, what is it going to return? It's going to return a pointer to that file object. And I use that pointer to manipulate the file. Okay, so fpointer, firstly I test. If for some reason the program couldn't open a file, say for example the hard disk is full, there's no more space on the hard disk, then this function is going to return a pointer called null. So it's my responsibility as a programmer to test for null. If this pointer return value was null, then the file couldn't be opened. There's no way for me to open that file. Otherwise, I'm going to start writing content to the file. So here we use the routines called fprintf. So it's similar to the printf routine, but the first argument is this pointer to the file. So it's fprintf, we pass it the file pointer, and we pass it the text that we want to write. So over here we write a star, then we write a %s, so we're going to specify a string. What string we're going to specify? This one that we've defined there at the top, a single line of text. And then afterwards we write a star again, and then we're going to output our integers and our float. So it works exactly like the printf routine. You just have to remember it starts with an f, and the first argument that it takes is this this pointer to the file. And then, very important, we close it again at the end. Okay, so let's see what I'm going to build it. There's going to be warnings because there's a lot of unused variables, but let me just see if it did compile. Yeah, build finished. I'm going to run it. Okay, so essentially I haven't written anything to screen except writing content to file. And if I now look at, for example, I open my Windows Explorer. It's my Windows Explorer, and I go to my directory where I have my Eclipse workspace. We look for it. I see there's my text file, CP143 test.txt. And I can open it in a word processor, and there I see the output, a single line of text, my int equals 5, and my float equals 1.35. Okay. So, let's see, the file is there. What I now want to do is I want to see now what happens if we modify some of the text that we're going to output and run the program again. So take note of that. Yeah, so let's have a look. Let's look again at the file content. A single line of text with 2 ampersands at the bottom. My int is equal to 5 and my float is equal to 1.345. All positive numbers, and this text says that. Now, let's open my program again. What I'm going to do now is I am going to change, I'm going to run it again, but I'm going to change my input arguments. I'm going to say, let's say this is now new content, and I'm going to make these numbers negative. My int is -5, and my float is -1.35. Okay. Let's see what's going to happen if I build my program. Well, if I run it again. But first I'm going to build it. And now I'm going to run it. So all that's going to happen is the content is just going to be written. So I still have my file, 1.43 test. Let's see what its content. Now its content has been updated with the new information that I written to it. This is now my new content, and my int equals -5, my float equals -1.345. But now, what happens if I don't want to lose that information? I want to keep my previous information. What am I going to do then? Then I'm just going to change this W that says write to A that says append. And let's change some of the values. This is the third time I write content. Okay. And let's essentially increase this a bit. Sort of double it in a way. Okay. Make it positive again. And let's write out or keep one positive and one negative so we can clearly distinguish that this is our new information. But now we've opened our file in a different mode. We've opened it in the append mode. So let's compile our program. Okay, a couple of unused variables, don't worry about that because we haven't used these, that's all it says, but we're going to use them now so they will disappear. And we're going to run it. Writing content to file. What is the content of this file now? Now you see that apart from my previous content that was there in the file, I've now also added the new content that I specified. Let's run it again. So there's 2 blocks of new content. Let's, for interest's sake, I'm just going to run it again. And now a third time there will be new information. Okay, so you see that's the difference between write and append. Okay, now let's try and extract information from this file. So what we have now is essentially we've got our information here, and we're going to call our function read content from file. So let's uncomment this, read content from file, and we give it the exact same file name over here. Or let's test something. Let's see. Let's call it some file.txt. Okay? We're going to build it. So what is important at this moment? This file, some file.txt, does not exist. This one does not exist. It's not here. So I'm going to try and open a file that's not in my directory. Let's see what my program does. I've got my command line open over here so that I can nicely see what my program is doing. Let's run it. Okay. Error. File could not be opened. Okay, so what happened? My program was trying to open a file. The file wasn't in this directory. So if I look at my routine over here, this is my routine, read content from file. I'm going to try and open it. If pointer equals if open, but this if open returns a null pointer because it couldn't locate that file. And that's why this message over here was printed out. So let's fix that again. Let's call our file name that is initialized over there. It should find it. Let's look at our file again. We open it. This is what our file looks like. Contains quite a bit of information. And I'm going to, first thing I'm going to do in my read content from file routine is I am going to, after opening the file, I'm going to call fgetS. So if you hover over it, you can also see the description of fgetS in Eclipse. It reads characters from this file pointer. It's going to read 29 characters, and it's going to store it in this variable called line of text. Now, line of text I have specified over here. So let's see what this is going to give out. Then after fgets, I'm going to, let's print this out first, and then we do this part. So I'm going to comment this out. Sorry. Okay. And we build it. A couple of warnings because we're not using the variables. Okay. So we're going to read content from the file. This is just a notification. Then it's going to read a line of text, store it in this buffer, this variable, this array line of text over here. That's a 30-character array of 30 characters. It's going to read from my file 30 characters and store it in this line of text. And when is it going to terminate? When is it going to stop? So if I look at my file over here, it reads this first line. So if getS reads a line until it gets a new line character. Okay, so for example, let me show you here. Let me change this to this. So I've added a new line character over here. What's going to happen now when I run my program? So if I run my program, it only prints out this first part before the new line is obtained. Okay, so if getS reads until it gets a new line, then it moves over to the next line. So where would my file pointer now be? If I look at this again, I call fgets again. What is the second line that's going to be printed over here? Is it going to go back to the beginning and print this line out again? Or is it going to move on to this part and print that out? Let's run it and see what happens. So I close my file here and I run. I compile it because I've changed the code now. So I compile it over here. I run and I run it. Okay. Yeah. It printed out this now, and the next time this file pointer moves on sequentially to the next line in the file. So if I look here, my file pointer in the beginning was here. I called fgetS, and the file pointer was incremented sequentially to point to that part. So if I call fgets again, it's going to move to this part. Okay, so that's what we mean with sequential access. All right, so yeah. Hey? Yes, it's a line. What fgets does is it reads, so it reads this text file, it reads a line until it encounters a new line character. Then it stops. That's the information that it draws. Some typical issues with fgets that you should be careful of is make sure that this array in which you store your results is big enough. If this line is longer than the buffer, then you're going to lose characters, you're going to lose information, or you're going to run into segmentation violations, issues with memory access. All right. Yeah, typically you can make your buffer big enough to you can define some max string length something, and then you can go ahead like that, for example. Let's look at another way, or let's look at an alternative approach as well. So this alternative approach is, we've looked at fgets now. Okay, so let's comment this out, and I'm going to open this part. Okay, so now here we're going to use a while. We have not detected the end of file. We're going to print out the line of text. So this over here is also using fgets, but it shows you, instead of how to read line for line, now the file pointer updates, we're going to read all the content from the file. How are we going to do that? So we're going to use a while loop to iterate until we get the end of file value over here, and we're going to print out this line in each case. So let's build it. We're going to run it. And as you can see over here, all this content that I show you here should be exactly all the content that's in my file over here. Okay. So that's how I iterate over my file, also using fgets. Reads until it gets a new line. And I've just done it inside of a while loop, while I've not encountered the end of the file. Okay, so now if you want to go back to the beginning, you can call this function rewind, and you give it the pointer. But what I'm more interested in is reading character for character also. So what is that going to do? We get into our function read content from file. We've opened it. We point to the first character, this one, and we call the fget C routine now. So file get character, and we give it the file pointer, and we print that character out. So let's build that and see what's going to happen. And as expected, it prints out the first character, which, if I open my file again, is equal to that ampersand. That star, asterisk. All right. Now, what we can also do is, this was fget S, fget C. Yeah, we can also call fscanf. So fscanf as well reads. Okay, we need to do this. Okay. First run the code, and then I'll explain to you what's happening. Okay, so what is happening over here is we are reading content from a file, and essentially, if I open my file, we are at the beginning here. Let's create it like this. So, and I'm going to simplify my file a bit. So I'm going to just create it like this over here. So my file is very simple, contains only that information. And just to avoid confusion, I'm not going to write any more content to my file. So I'm just going to comment out that function. So I'm only reading content from my file. And my file is very simple. It just looks like this. One line, this is now new content, followed by an integer and a float. So let's build this. Let's run this. Okay, so what happened over here? We read a line using fgetString. Passed it the file pointer, and it's stored in this buffer, and we print out this line over here. And I said this function will read a line will read a line from the file until it gets a new line, so we print it out. So that's fine, that works as expected. What about this fscanf? Essentially what this does is it reads information from a file specified in this format specifier and stores it into string 1, string 2, and also my float. So what this does is it reads the information that is contained in this part of the file. Some string value, an integer, again some string value, and a floating point number. So some string value followed by a string followed by a floating point number over here, and we print out the value of the float. It prints out the integer value over here, so let's just make sure we revert back to the beginning. Okay, let's simplify it perhaps a little bit more. Okay, only 2 lines, so we have a string value and we have an integer value over here. Okay, let's just fix this. So we're reading a string and we're reading a it stores it in float, so this has to be a float. 5.0, 5.12. Store it as okay, so I have a string line over here, and then I have some text. It says my float equals, and I have a floating point digit over here. So what our goal is we want to read a string, and then we want to read a floating point variable. And we want to store the string part of that line in this variable called string. We want to store the float part of this line that we read from file in this floating point variable my float over here. We print it out. My float is defined as a float over here, and string 1 is a character array as shown over here of size 20. Okay, so let's build this and let's run it. Ooh. Giving 0 over here. Okay, just hang on a bit. Just going to remove the white spaces there. So what happens is the fscanf routine sometimes works a bit different with white spaces. Okay, we run it. No, it still gives 0. Okay. Okay, this part we can look at this part using the fscanf function. We can look at in a little bit detail next time. I just want to see why it's printing out 0. We just stop this first, and then we can try and debug it. Okay. All right. Sorry about that. Bit of a delay. What we wanted to do now over here, just to recap, is we had a file that looked like this. So we had a line. This is now new content followed by my float equals minus 5.12. So what we've done is we wanted to create a function over here, and we're reading this line using the fgetS routine, but also the fscanf. And in both, so what the F does is it reads until it gets a new line, and stores the result in this line of text. The scanf has also got similar behavior, but instead of, it's got a little bit of a different formatting over here. It reads, gives it the file pointer in the beginning, and then it scans if this string, this declaration that you put over here, it puts it into this string variable that you see over here, so that we defined over here. And then we just print the value of string 1 out again over here. So I think what we can try quickly is we can put this over here on a new line. So this will be our string. But this we can specify as a float. So let's see if we can read this directly as a floating point number from the file. So what we're going to do is I'm going to print it out like this. And let's build it, and let's run it. Okay, so as you see, I can directly read from the file using functionality that looks very similar to the scanf routine. I can read, for example, this string directly, so this would correspond to this line over here. I can read a string, but I can also read a floating point number directly from the file using a %f specifier, which is similar to, for example, when I read a character from the keyboard. When I ask the user for a character, I also call scanf, and if I read a floating point, I store it in a %f. So in a similar way, I can read the input directly from this file now. Okay, and then at the end, just very important, remember to close it using the fclose routine over here. All right, do you guys have any particular questions about ASCII files? Next week we're going to look at binary files and also random access. Okay, if not, go through. You can go through this example again. A lot of it is in the slides. In the slides, let me go back to it. In the slides, the only difference is it is split into two different parts. So the first part writes out all the information, and the second part just reads all the information again. All I've done in my example over here is I've just combined it into one program and put the two different parts in these two functions one called write content to file, and I pass it the file name, and the other read content from file, and I get the file name. So a good exercise for you guys would be to in write content to file, experiment, for example, with different values of this specifier. This is A for a pen. Use different ones. Try out, for example, a plus. See what's happening then. Try out W, and things like that. So yeah, so that you can get used to how files are written. We use the fprintf routine over here, and then reading the content from the file. Again, you can open the file in different modes, and then there's different ways to get information from the file. Always remember, after opening the file, check what the pointer is. If it's null, that means the file wasn't opened successfully, and you need to capture that behavior. Otherwise, you can process it. Okay, so that's it. Next week, we're going to look at binary file writing. Enjoy the rest of the week, and also good luck with the practical.